Today we're going to start talking about sequences, and we have two types of sequences that we talk about in this unit. One is arithmetic sequences and the other is geometric sequences. And today we're starting with the arithmetic sequences. So you can see in this table, if we go back to thinking about when we talked about modeling functions earlier this unit, and I look at this table, so here's number of weeks and an account balance. And we notice that there's $10 being added each week, okay? So there is a common difference. Or this has a linear, it would be a linear model. And so our arithmetic sequences they're a linear model. Now, the way our sequences are written out won't be in a table like this. It'll be listed. So say I have a sequence from this table, how it would be presented to me. It's saying, here's a sequence of numbers. And from that, we could find the common difference. And from that, we could also be able to predict future values. So say find the 34th term of that sequence. We're going to discover a formula that would allow us to do that without having to list out all of the terms. And then there's some kind of notation that goes along with sequences. So for our sequences, our first term we call A sub 1. So there's A1, this is A2, A3, A4, A5. Okay, my common difference is 10. And so if I were to, so this is 1, 2, 3, 4, this is A5. And I could ask questions like find A45, okay? Find the term 45 is what that would mean. So we get used to this notation while we look at sequences over the next couple of days. So let's define our arithmetic sequence where each term in this sequence is found by adding, of course, you could be adding a negative, so your common difference could go down, by adding a common difference which we call D in our formula to the previous term. There's our definition of an arithmetic sequence. And we have another example of a sequence with a common difference below. So it says find the next four terms of arithmetic sequence 91, 83, 75. So we can see that the change from 91 to 83 would be -8. And then from 83 to 75, we'd be taking away 8 again. So my common difference is -8. And so I can just list the next four terms of the sequence by continuing to subtract 8. So from 75, if I subtract 8, that brings me to 67. Take away 8 again, that brings me to 59. Take away 8 again, 51. Take away 8 again, 43. So I can list terms, given the beginning of a sequence, I can continue that sequence. What gets more challenging is if you were asked to say, find the 100th term of that sequence. We wouldn't want to list all 100 terms. We'd want to be able to have a formula, a way of getting there. So let's figure out what that formula would be. So I'm going to look at this sequence up above. So 91, 83, 75, 67, I'll stop there. Okay, so that's the sequence I have up above where I'm taking away 8 from each term. Now, for notation or for a symbol here, 91 we will call A sub 1, 83 A sub 2, this is A sub 3, A sub 4, and then so on. We could have an nth number term. We could have a 50th term or 1000th term. We can put in any number for n here, and n would be the number of term in that sequence. Okay. So there's my sequence from above. Here's the symbols for it. Now we're going to rewrite that sequence from above, but we're always going to express it in terms of the difference in the first term. So for 91, we don't have any difference there. We just have 91. So I'm going to say plus 0. For 83, if I need to use the first term and the difference, then I'll write 83 as 91 take away, or sorry, adding -8. Because we want to write it as addition. And for 75, if I have to use the first term and just the difference, then I'll have 91 plus 2 differences of -8. Then -8 and then -8 again. And if I wanted to write 67 with just using the first term and the common difference, then I'd have 91 plus 3 differences of -8. I've subtracted 8, and I subtracted 8 again, and that's how I got there. Okay. Now, what you might notice here is that I have 3 -8s here, 2 -8s here. We can write in that we have 1 -8 in this term, and then we have 0. If I look at my symbols up above, for my first term, I added 0 differences. For my second term, I added 1 difference. For my third term, I added 2 differences. And for my fourth term, I added 3 differences. So if I wanted to find any term in this sequence, I could take my first term and I could add 1 less than the number of term I want times that difference of -8. Do you see how it's always 1 less? So if I wanted to find the 50th term of this sequence, then that means I'm taking away 49 -8s to get there, 1 less than 50. And so using our symbols up above, that means here I have a sub 1 plus 0 differences. And then I have a sub 1 plus 1 difference. And I have a sub 1 plus 2 differences, and a sub 1 plus 3 differences. And so I can always find any term of the sequence using the first term plus 1 less than the number of term I want to find times my difference. There's my formula. Okay, we just discovered our formula for our arithmetic sequences. Okay, we can always start with the first term and add to it 1 number less than the term I want to find times the difference. Okay. So when you're ready, if you need to pause that to fill in your table, do so. But when you're ready, flip our page and let's rewrite that formula for our arithmetic sequences. So to find any number term, we call that a sub n equals the first term plus n minus 1 times our difference. So let's just make sure we understand what all these parts are for when we use it in a minute. This is the nth term, so I can plug any value in for n. I can find the third term, or I can find the 103rd term. And if I was finding the 103rd term, when I wrote this, I would write a sub 103. Okay, I'd plug in whatever term I'm looking for n. A sub 1 is my first term, so we do need to know what our first term in that sequence is. N is whatever number term I'm looking for. Again, if it was 103rd term, I'd put in 103 for n. And D is our common difference. Okay, so there's a few things we want to be able to do with these sequences. First, let's start by not even using the formula at all. I don't need the formula to do the next 4 questions. So sometimes we're just going to be asked to continue the sequence. So what would the next 4 terms be? So to do that, all I need to do is determine what the difference is. So going 26 to 21, 21 to 16. And I would say that the change there, the difference is that I'm taking away 5 each time. So I can list the next 4 terms, take away 5 more is 11, take away 5 more is 6, 5 more is 1, and -4. Just listing the next 4 terms in that sequence. I don't need this formula to do. I could have fractions, 1/2 to 1, 1 to 3/2, and for that, I would say that each time I'm adding positive 1/2. So if I were to add another half, so from 3/2 add another half, that's going to be 4/2 or 2, plus another half would be 5/2, plus another half would be 6/2 or 3, plus another half would be 7/2. And so I can list the next 4 terms of a sequence, even if I have to add a fraction. So now you go ahead, pause the video, and fill in the next 4 terms for numbers 3 and 4. Okay, so there's my work for 3 and 4. On 3, I have a common difference of 6, and I listed the next 4 terms. And on 4, my common difference is -5, and I listed the next 4 terms. Okay, let's look at the next thing that we might be asked to do. So on these examples, it gives me some information and asks me to find the nth term, which means, for example, in number 1, it says n equals 14, which means it wants me to find the 14th term in that sequence. So if I go back up to my formula, I'm plugging 14 in for n. And I can plug in what it gives me for the first term, n, and my difference, and I'll be able to just do the math there. So my first term is 3 plus my formula. So let me rewrite my formula up above. A sub n equals my first term plus n minus 1 times my difference. That's my formula from up above. So the 14th term would be the first term plus 14 minus 1, or 13, times my difference of 7. Okay. So then I want to make sure that I follow order of operations and do this multiplication first. So I'd have 3 plus 13 times 7 gives me 91. And the 14th term would be 94. Okay, because I don't want to have to sit here and start at 3 and keep adding 7 until I get to my 14th term. I want to be able to have a formula and a way of getting there without having to list a bunch of terms. I mean, 14 might not be so bad, but look at our next one, right? 101st term. I don't want to list 101 terms to be able to get that answer. So for our second example, again, here's our general formula. N is 101. So I'm going to say A sub 101 is going to equal my first term, which it tells me is 35, plus n minus 1. So 101 minus 1 would be 100 times my difference, which is 3. So I have 35 plus 300. A sub 101 is 335. There's my 101st term. If I started at 35 and I kept adding 3, and I did that 100 times till I get to my 101st term, then I'd be at 335. Okay. It says write an equation for the nth term of each sequence. So from this, we're not finding a specific term. We're taking the information and we're going to write an equation that could be used to find any term. So here I see that my first term is 7. So essentially we want to find these pieces of information. What's the first term and what's the difference? My first term is 7. And my difference, as I look from 7 to 16, 16 to 25, 25 to 34, that each time I'm adding 9. So putting that into my formula, the nth term of each sequence, A sub n, will equal the first term plus n minus 1 times 9. Okay, and this is fine. This version of that equation is fine. So this is using the formula we have up above, plugging in A sub 1 and my difference. We could also write it as a linear equation like this. So it will look like y equals mx plus b. So I can take, and at times you may see an equation that looks more like a linear equation, but we would know that our arithmetic sequences are the linear ones, And that's what would help us kind of link that equation into which sequence we're talking about. But kind of leaving it here is fine. It works, but we can also clean it up a little bit. So you may find on certain questions it asks for the linear equation that would model that. Okay, which just means, okay, I'll distribute that difference through. And then I can write this as a sub n equals 9n, combining like terms, minus 2. So this equation here would also work to find any term in this sequence. It looks different, right? It doesn't follow the formula for arithmetic sequences. We took the formula and distributed and moved some things around, and it looks like a y equals mx plus b equation. But if I wanted to find the 100th term of this sequence, I could either plug in 100 for n here, or I could use this equation and plug in 100 here. Okay, they will both work, just different versions of the same thing. Okay. So on this next one, I want you to go ahead and determine a sub 1, what's my difference, and try to write the formula for that sequence. And if you want to also try to write what the linear form of that is, that y equals mx plus b form of that equation, that would be good practice as well. So pause your video and do that. Okay, so for our second example here, our first term is 18, and we have a common difference of -7. Here's our formula for that arithmetic sequence. And if I clean that formula up, here it is in kind of y equals mx plus b form, being really careful that when I distribute that difference, it's changing those signs. So it's giving me -7n and +25.